So what if the greatest feeling of productivity isn't, building something new, but actually just completely tearing down everything you just built?
Oh, that is a very specific, very intense kind of joy.
Right. It really is. And today, we are dropping into a highly specific snapshot of a programmer doing exactly that.
Yeah.
We've got our hands on a blog post from June 25th, 2026. It's written by a developer named Ang, and it's titled Notes on Haskell Programming, Part 170.
Part 170.
Yeah, Part 170, Unifying Text Generation Flow, which, the title alone is just a lot to take in.
It really is. You hear Part 170 and you immediately know this is not just a weekend project.
No, not at all.
We are witnessing a really deep, obsessive dedication to refining a personal system here.
Exactly. And that level of dedication is where the most fascinating insights hide, I think.
Absolutely. And I should say, for anyone tuning in who might be feeling like a bit of apprehension at the phrase Haskell programming, there's really no need to worry.
Yeah, we aren't going to bog you down in impenetrable code.
Right, because we are really examining the underlying philosophy of this post today. The focus is on a very universal psychological journey.
The realization that you've been doing something the long, painful way.
Yes. Followed by that immense, overwhelming relief of finding a built-in shortcut that was just, hiding in plain sight the whole time.
Hiding right under your nose.
Yeah.
So our mission for this deep dive is to unpack that brief but really dense aha moment of code refactoring.
Yeah, to translate those technical mechanics Ang is describing into a broader lesson about efficiency.
Right. So to set the stage, Ang is working on this massive pet project using Haskell, which, if you don't know, is a notoriously rigorous programming language.
Very rigorous.
And the catalyst for the specific post is a sudden realization about a piece of software they were already using in the project. It's called Pandoc.
Pandoc, yeah.
I've actually come across Pandoc before. It operates like a universal translator for documents.
That's a great way to describe it.
You feed it a markdown file, and it just spits out a beautifully formatted PDF or an HTML web page.
It handles almost any document conversion you can possibly imagine. Developers rely on it heavily because, frankly, parsing text formats is an incredibly tedious task. But here's the thing. Before this particular realization, Ang had actually built a completely custom parallel system within their codebase strictly to handle plain text conversion.
Wait, really? So they were using Pandoc for certain things, but they had written a bespoke engine just to generate plain TXT files.
Exactly. They were doing it the hard way.
Okay, let's unpack this because, it's like spending weeks building a custom, elaborate coffee machine from scratch, right?
Yeah.
Only to, read the manual of your kitchen blender and realize it has a built-in world-class barista mode.
That is exactly what happened here. Ang discovers this hidden feature. It turns out Pandoc actually supports reading and exporting plain TXT files natively.
The tool they were already running had the exact capability they spent hours, maybe even weeks, building from scratch.
Right. And this discovery is the domino that just knocks down an entire section of Ang's custom code.
Because previously, having that custom system meant Ang had to manually govern every single rule of text conversion, right?
Right, every single one. But now they can abandon that custom-built path and route everything through what Ang refers to as the Pandoc Native API.
But, why rewrite it if the custom branch already worked? What is the actual value of unifying this under the native API?
Well, the shift from a custom build to a native API represents a massive reduction in something software engineers call technical debt.
Technical debt.
Yeah. When you build a bespoke process, even if it functions flawlessly the moment you finish it, you are essentially taking out a loan against your future time.
Because you have to maintain it.
Exactly. If the main system updates, your custom branch might break. If you find a bug, you now have two completely different areas of code to investigate.
I always think of technical debt like patching a leaky roof with duct tape.
Oh, that's a good one.
Yeah, instead of replacing the shingles, it stops the water today and you feel great about it.
Yeah, you feel like a genius.
Right. But you haven't actually solved the structural problem. You just deferred it.
You kicks the can down the road.
Exactly. And when a heavy storm finally hits, like a major system update, that tape is going to fail and the entire ceiling comes crashing down.
Yep. Maintaining that parallel custom text generator was basically Ang's duct tape.
Wow.
The longer you maintain a custom branch, the more expensive it becomes to keep it aligned with the rest of your ecosystem.
So by shifting to the native API, Ang is unifying the document conversion logic.
Yes. The developer is offloading all that mental burden of maintenance to a robust, standardized system that, thousands of other contributors are constantly testing.
Right. And the actual implementation of this shift in the code is where Ang mentions running everything through something called the Pandoc IO monad.
Ah, the IO monad.
Yeah. And whenever I see the word monad in a programming context, my eyes just tend to glaze over.
A lot of people have that reaction, trust me.
But I know Haskell is a purely functional language, right? Meaning it treats programming like strict mathematical equations.
Exactly. If you put a 2 in, you always get a 4 out.
No outside interference allowed.
None at all.
So in my head, I'm picturing the IO monad as a sort of digital hazmat suit.
A hazmat suit. I like that.
Because reading and writing files, which is what Pandoc has to do, is inherently messy and unpredictable. It interacts with the outside world.
It does, yeah.
So the monad is the hazmat suit that lets the pure, pristine Haskell code handle the dirty work of file conversion without, contaminating the rest of the system. Am I close?
You are incredibly close. That is a highly accurate way to visualize it.
Oh, awesome.
Yeah, functional programming languages absolutely despise side effects.
Side effects.
Yeah, things that change the state of the system outside the function itself, like saving a file to a hard drive or, printing text to a screen.
Because that ruins the pure math of it all.
Exactly. So the IO monad acts as that highly controlled environment or hazmat suit, like you said, where those necessary interactions with the outside world are permitted to happen.
But they happen safely in a sequenced order.
Right. By moving the text generation inside the Pandoc IO monad, Ang ensures that the plain text export is governed by the exact same strict, safe rules as every other document conversion in the project.
It's a completely unified pipeline now.
Completely unified.
There is a very specific kind of relief in seeing hundreds of lines of fragile code turn red and just disappear in a version control system.
Oh, it's the best feeling. Deleting code is better than writing code.
Right. When you look at the before and after code diff that Ang provided in the post, it is incredibly satisfying.
They really cleaned house.
They completely gutted something referred to as the custom AST implementation.
Yeah, they deleted massive blocks of code that were doing manual mapping.
There were functions like block tow lines that literally had to check, is this a header block? Okay, do this. Is this a paragraph block? Okay, format it like that.
It was micromanagement at a microscopic level.
Yeah. So we should probably break down what that AST actually is.
Yeah, AST stands for Abstract Syntax Tree, and it explains exactly why this micromanagement was so burdensome for Ang.
Okay, so what is it exactly?
Well, when a computer reads a document, it doesn't read it like a human reads a book, left to right, top to bottom.
Right.
It parses the document into a tree-like structure. Think of sentence diagramming from elementary school.
Oh, wow. Yeah, where you break a sentence apart into nouns, verbs, and prepositional phrases.
Exactly. And AST maps out the document conceptually. Like, here is a title, here is a list, here is a bolded phrase inside the second bullet point of that list.
So because Ang was handling this manually before, they had to write code that traversed that entire tree structure all by itself.
They had to handhold the computer through the whole thing.
They had to tell the computer, when you find a node labeled header, insert a blank line before it and capitalize the text.
Yeah, they were manually flattening that complex three-dimensional tree back into a two-dimensional string of text.
That sounds exhausting. The burden of understanding document grammar basically fell entirely on Ang's shoulders.
It did. But when they deleted that custom mapping, they replaced it with a single call to Pandoc's native writePlain function.
Wow. Just one function.
Yep. They handed the entire conceptual map over to a system that already natively understands what a paragraph looks like and how a header should behave.
It's like they fired the manual translator who was converting a book word by word and just handed the manuscript to a fluent native speaker.
That's a perfect analogy. It completely removes the need for the developer to teach the computer basic document structure.
Okay, but in that same line of code where Ang delegates the heavy lifting to writePlain, there was this format options configuration that really caught my eye.
Oh, the columns.
Yeah. Ang explicitly passes in a rule that says writer columns at 79.
Yes, that is a very specific detail.
Right. Because if we were leaning on this brilliant unified native API to automate everything, I find it fascinating that Ang felt the need to hard code such a specific, seemingly random number into the layout rules.
It does seem random at first glance.
Like 79 feels so deliberate. Why not 80? Why not 100?
Well, it is entirely deliberate. And that specific number is actually deeply rooted in the physical history of computing.
Wait, really? The physical history?
Yeah. Long before we had, ultra-wide high-definition monitors, data was fed into computers using Hollerith punch cards.
Oh, like the actual cardboard cards with little holes punched in them.
Exactly. The standard IBM punch cards, which were introduced way back in 1928, had exactly 80 columns.
80 columns.
Yeah, you could punch 80 characters of information onto a single physical card.
So the hardware literally dictated the format of the data.
It dictated everything that came after it. Because when video terminals were eventually invented to replace those physical punch cards, the manufacturers naturally designed the screens to display 80 columns of text.
Just to match the existing punch card standard. That makes so much sense.
Right. But programmers quickly learned a hard lesson about early terminal software.
What was that?
If you wrote a line of text that was exactly 80 characters long, hitting that absolute edge would often cause the terminal to glitch out.
Oh, no. Like it didn't know what to do at the exact border.
Yeah, the cursor would wrap to the next line in an unpredictable way, sometimes creating awkward blank spaces or just breaking the visual flow of the code entirely.
So stopping at 79 characters became like the industry standard safety buffer.
Exactly. It ensured the system wouldn't try to auto-wrap your text and break the layout.
That is wild. It's fascinating how a physical piece of cardboard from the 1920s is still casting a shadow over a highly advanced Haskell codebase in 2026.
It really is. The legacy component is a huge part of it, but the 79-column constraint has survived this long for another reason too, one that's rooted in human cognitive psychology.
Really? Like how we read?
Yeah. Reading a massive block of text on a modern, ultra-wide monitor is actually quite exhausting for the human eye.
Oh, sure, because your eyes have to travel so far horizontally, it becomes difficult to track back and find the start of the next line. You just lose your place.
Exactly. The scientific term for that tracking movement is a saccade.
A saccade.
When a line of text stretches infinitely across a screen, the saccadic return jumping your eyes back to the left margin requires a lot more effort.
So you get tired faster.
Right. The 79 character limit happens to fall roughly within the optimal line length for readability.
Wow. So by setting writer columns equals 79, Ang guarantees that no matter where this plain text file is opened, whether it's on a vintage terminal, a modern text editor, or a massive curved monitor, it's going to look good.
It will render in a narrow, readable, perfectly constrained column every single time.
It is basically an act of digital typography. Ang is setting the margins on a novel so the reader doesn't get a headache.
That's a great way to put it.
And actually, speaking of typography, this focus on visual aesthetics transitions us perfectly into the final detail of the blog post.
Right, the normalization step.
Yeah, because Ang doesn't stop at line length. They are also obsessed with the specific punctuation marks being rendered.
They really care about the details.
And if you are listening to this, you might be feeling a bit of skepticism right now, because we just talked about the massive relief of tearing down a custom system to rely on a native API.
Yeah, simplifying everything.
But Ang actually introduces a new, bespoke detour right before the document is finalized.
It's true. They unify the macro structure, but they still inject a micro-customization.
Exactly. Ang introduces this small function called tidy inline, and the code relies on a command simply called walk.
Walk, yeah.
The logic basically dictates that if a certain flag is triggered, the system will walk this tidy inline function through the entire document.
And the result of that walk is very specific.
Very specific. When you look at what tidy inline actually does, it is replacing standard curly quotation marks, the ones that look like tiny 6s and 9s.
Right, standard smart quotes.
Yeah. It replaces those with East Asian corner brackets.
Which are those rigid right-angle brackets.
Exactly. They look like little borders around the text. Ang even mentions they will dedicate their entire next blog post to this specific normalization.
Which is amazing.
I can hear the listener asking right now, why rewrite your entire document pipeline just to change how a quotation mark looks?
Well, it highlights a crucial philosophy in system design, honestly. It's about separating infrastructure from interior decorating.
Oh, I like that. Separating infrastructure from interior decorating.
Yeah. You want a massive standardized system like Pandoc to pour the concrete, build the walls, and route the plumbing.
You don't want to worry about how to save a file or format a paragraph.
Exactly.
Right.
But you still want the power to bring your own vintage lamps into the living room.
And the walk command is the tool that lets them hang those lamps safely.
Safely is the key word there.
Right. Because when I read the word walk in the context of that abstract syntax tree we discussed earlier, I picture like a tiny digital inspector.
A tiny inspector, yes.
It isn't just blindly scanning a flat page of text like a standard find and replace tool, right?
Yeah.
It is physically pacing through the branches of the document tree, checking every single leaf. Am I interpreting that correctly?
You are. And that interpretation hits on the fundamental difference between a blind search and a structural traverse.
Because a basic find and replace could mess things up.
Oh, a standard find and replace is incredibly dangerous in a programming environment.
Why is that?
Well, if you tell a basic script to replace every single quotation mark in a document with a corner bracket, it has no context.
Oh, right.
It might accidentally replace a quotation mark that is secretly part of a URL, or one that's buried inside a block of raw HTML code that isn't supposed to be visible.
And suddenly your hyperlinks are completely broken and the entire file is corrupted.
Exactly. A blind search cannot differentiate between text meant for the reader and text meant for the computer.
But the walk command understands the AST.
Yes. It travels through the structural map of the document and isolates only the inline text elements, the actual paragraphs and sentences meant for human eyes.
So it ignores the code blocks.
It skips the metadata entirely, and it surgically alters only the specific quotation marks Aang wants changed.
It really is surgical precision. You're letting Pandoc do all the heavy lifting, but you maintain the ability to automatically scrub and reformat text to your exact, highly specific aesthetic preference every single time you hit compile.
Yep. You get your beautiful corner brackets without ever lifting a finger or risking the integrity of the codebase.
That balance between macro delegation and micro control is really what makes a pet project so rewarding.
It is a masterclass in refactoring, honestly. Aang didn't just change the code for the sake of trying a new tool.
Right.
They recognized a point of friction maintaining a parallel system, and they eliminated it.
They leveraged a native capability to reduce their own mental load.
Exactly, freeing up their energy to focus on the intricate, personal details that actually bring them joy, like typographical corner brackets.
Well, we have covered a lot of ground diving into part 170 of Aang's Haskell journey today.
We really have.
We started with the sheer joy of discovery, exploring how finding a hidden feature in a familiar tool can fundamentally alter your workflow.
Yeah, the Pandoc realization.
Right. And then we looked at the immense satisfaction of deleting bulky manual code and letting a native API like writePlain take over the stressful job of document translation.
Goodbye, custom AST.
Exactly. We traced the history of the 79-column limit, from physical IBM punch cards in the 1920s all the way to modern cognitive readability in saccades.
Which is still my favorite part.
It's so cool.
Yeah.
And finally, we explored the elegance of using structural tools like the walk command to surgically insert personal touches, like those corner brackets, without destabilizing the broader system.
And I think the core takeaway here extends far beyond software engineering.
Oh, absolutely.
Whether you are managing a team, organizing data for a project, or simply trying to coordinate your daily schedule, the pursuit of the native API is universal.
It really is.
It is the pursuit of the built-in, standardized way of operating that allows you to stop fighting the friction of your own custom solutions.
Which brings me to a final thought I want to leave you with today. If a highly complex 170-part Haskell text generation flow can be radically streamlined simply by realizing an existing tool already has the capability built in.
Yeah.
What custom convoluted processes in your own daily life are you stubbornly maintaining?
That's a great question.
Think about the elaborate, stressful workflows in your job or your hobbies, or even just how you manage your household chores.
Way out of them.
Are you keeping them alive out of habit simply because you haven't checked to see if the tools you already own have a native solution?
It's so easy to just keep doing what you've always done.
It really is. Maybe it is time to read the manual for the tools sitting right in front of you. Thanks for taking this deep dive with us.